All right, let's get into it. Today, we're taking this, a hospital fire safety drawing, a single, really complex document, and we're going to break down exactly how it goes from lines on a page to a real life-saving system. This plan, right here, is our single source of truth, and we're going to follow its journey from concept all the way to reality. So, here's the game plan for today. First, we'll learn to read the language of the design. Then, we'll translate all those symbols into an actual list of materials. After that, we'll map out how it all gets built, step by step. Then, we'll cover how we make sure it's all done right, and finally, how we prove that the whole thing actually works. Let's get started.
First things first, we've got to understand what we're even looking at. This part is all about reading the drawing, identifying the core systems and the rules that dictate how they all fit together.
Okay, so this plan is really showing us three interconnected systems working in harmony. You've got your firefighting system, that's the main network of red water pipes and sprinklers. Then you have fire suppression, which uses a special gas, FM200, to protect really critical areas like server rooms where water would cause a ton of damage. And tying it all together is the fire alarm system. Think of it as the brains of the operation, the nervous system that detects a fire and tells everything else what to do.
Now, this is absolutely crucial. These codes you see here, they're not just suggestions. These NFPA standards are the official rulebook, recognized worldwide. Things like NFPA 13 for sprinklers or NFPA 72 for alarms. Following these to the letter is what guarantees the system will work when you need it most, and it's what makes it legally compliant. So how do we know there's actually enough water with enough pressure to put out a fire? Well, that's where something called hydraulic calculations comes in. It's the core engineering that underpins the entire design. Engineers figure out the worst-case scenario, the area that needs to be covered, the amount of water needed per square foot, and that tells them exactly how big the pipes and how powerful the pumps have to be.
Okay, we understand the theory. We can read the map. Now, we have to turn all those lines and symbols into a real-world shopping list. This next phase is all about bridging that gap from the design on paper to the actual materials, the logistics, and of course, the cost.
So how do you even start? It's actually pretty simple. You take it one piece at a time. Let's look at this main red line right here. The drawing tells us it's a 4-inch diameter pipe. This is a main riser, and it's basically the backbone of the entire sprinkler system.
And there it is, the magic of translation. By simply measuring that line on the drawing and applying the correct scale, we figure out that we need somewhere between 120 and 150 meters of that specific 4-inch pipe. A line on paper just became a real quantity.
And then you just rinse and repeat. You do that exact same process for every single pipe on this drawing. From the 3-inch submains to the smaller 2-inch branches, all the way down to the tiny 1-inch pipes that drop down to the individual sprinkler heads. You do this enough and you get your complete piping bill of quantities, or what everyone calls a BOQ.
Of course, it's not just pipes, right? You do this for literally every single component. The drawing tells us we need around 300 sprinkler heads, maybe 15 hose reels. We also have to count up all the fire alarm parts. We're talking over 200 smoke detectors here, and all the pieces for those 4 specialized FM200 rooms. Every single nut and bolt gets counted before a single order is placed.
So, we know what we're building, and we know how much stuff we need to buy. Now we get to the really practical part, the how-to. What's the right order to actually install everything on site? Because believe me, the sequence matters a lot.
You see, you can't just start anywhere. There's a logic to it. You have to start with the main infrastructure, the big pipes. That's the skeleton of the system. Once that's in, you can start layering in the smaller components, like sprinkler heads, then the fire alarm devices, and you finish with the highly specialized FM200 gas systems.
Let's zoom in on just the piping for a second. Even that has a very specific order. First, you literally mark the routes from the drawing onto the ceiling. Then you install all the hangers that will hold the weight of the pipes. Only then do you start lifting and connecting the pipes themselves, and you always work from the biggest main pipes down to the smallest sprinkler drops. It's all about building a strong, stable foundation.
Okay, the system is starting to take shape, but is it being built correctly? And are they using the right materials? That's what this next part is all about, sourcing the parts and then checking the work.
You know, having a rock-solid procurement plan is so important. You can't just go buy any old smoke detector off the shelf. Every single item, from the pipes to the special fire-rated cables for the alarm system to the FM200 gas cylinders, has to be formally submitted and approved to make sure it meets the project specifications and those all-important NFPA standards.
And this right here shows the constant back and forth between doing the work and checking the work. For every single action the installation team takes, there is a quality check that follows. They install pipes, an inspector comes and verifies the hanger spacing is correct. They finish welding, the system gets filled with water and pressure tested to make sure there is 0 leaks. For those FM200 rooms, they even do something called a door fan test to prove the room is perfectly sealed.
We've made it to the final and honestly, the most critical phase. This is where we prove that all these different systems don't just work on their own, but that they work together flawlessly. This is the final exam before we hand the keys over to the client. Commissioning isn't just one test. It's a whole series of intense trials designed to simulate a real emergency. We'll pressure test the pipes again. We'll go to every single smoke detector and puff smoke at it to make sure it sends a signal. We'll even simulate a full gas discharge in the FM200 rooms to prove the entire cause and effect chain works exactly as it's supposed to. And the project officially wraps up with this, the final handover package. Look, this is so much more than just paperwork. This is the building's safety Bible. It has the as-built drawings showing where every single thing is, all the test reports and the compliance certificates. And most importantly, this is what's used to train the facility team who will be in charge of this system for decades to come.
And that's really the key thing to remember. The day the project is complete is really just day one for the building's safety. The installation is just a moment in time, but keeping people safe, that's a continuous, lifelong commitment.
Which brings us to a final thought. Once the system is built, tested, and handed over, the responsibility shifts. It moves from the construction team to the building operators. True safety really begins the day after handover, and it depends entirely on the ongoing maintenance, the regular testing, and the vigilance of the facility team who are now the guardians of this life safety system.